welcome back to the course. In this section 3.1, we are going to introduce a framework, specifically Spark or Apache Spark. What is Spark, right? Spark is a framework for distributed processing. I'm sure you've heard of MapReduce. So it's a streamlined or better version of the MapReduce, right? Like MapReduce is, you kind of have to write everything onto the disk, but Spark, it uses in memory, therefore it's more streamlined. So typically nowadays, companies are moving away from MapReduce and moving towards Spark. And then Spark applications can be written in Scala, Java, or Python. That's another reason why Spark is so popular, because it has a lot of API and then interfaces, so you can actually use the language that you're familiar with to really write Spark applications. So now why Spark? Obviously, right? You can actually analyze terabytes of data. So, big data, it's all about lots of data, right? And then it's definitely, it's proving to be faster than MapReduce, right? And then it's simpler. The setup is actually simpler than MapReduce API, so that's why a lot of companies want to use Spark instead of MapReduce. And the essence of Spark, right? So what's Spark? So Spark takes like MapReduce paradigm, so like the logic or the setup, and change it in some critical ways, right? A few things, right? So instead of writing single MapReduce jobs, Spark jobs actually has a series of map and reduce functions. You can actually see later. I'll give you an example. So you can pretty much sequence all your functions, right, by doing dot. So you can write dot, parallelize, and dot filter, and then dot collect, right? So, and then like I said, the intermediate data, right, is kept in memory instead of being written to disk, right? So that's why it's a lot faster and simpler and streamlined compared to MapReduce. And then this is actually a good diagram for Spark ecosystem. So you can actually see Spark Core API. You can actually, access this API through, all these things, right? Like R, SQL, Python, Scala, Java, right? That's why Spark is very popular because it's almost like language agnostic, right? It doesn't depend on a language. You can actually use, any of the language from here. And then you have all these blocks, right? Like almost like packages, right? That are sitting on top of the Spark Core API. So Spark, SQL plus data frame. So think of it as like SQL, more like SQL, or Pandas, think of Pandas data frame. And then streaming. This is actually pretty important. A lot of a major reason for people who are using Spark, because when you're talking about streaming data, that's where you have to write a pipeline that can adapt to the streaming data. And then MLlib, right? This is where we're going to be talking about in our next section, right? So machine learning, and this is like the machine learning libraries called MLlib. So Spark has this MLlib, and it's expanding dramatically. Now we have more, components to it. So that's great. And then GraphX, right? So graph computation, right? That's another silo that you can use. A lot of time, we'll talk about NetworkX, right? We're going to be talking about NetworkX in our next section, which is section 4. Sometimes the data is suited for a graph, right? Like the social media data is something like a graph. Think of it's a good graph representation. So you want to use GraphX instead of just a typical data frame. So, Spark has all this, right? That's ready to be imported and used. So now, I actually have another folder in this project folder so that you can use for installation. So just go through the steps to get Spark installed and set up everything. So, but the execution part, right, is like really, it's like this. So you have a driver, right, which we call it like Spark context. You have, Spark context, which interact with the cluster manager. And this cluster manager is sending this like all these things to cluster manager. And then cluster manager is managing the worker nodes. You can have many, many worker nodes, because remember, Spark is all about parallelizing, right? You're gonna have many things working in parallel. So you can have many workers, and then in here, in each worker, you're gonna have like executor and task, and then they can talk to each other, like, right? So, and then once you're done, then you can actually, like, the results will be sent back to, right, the Spark context, right? It will send back to the Spark context, and then you will be able to see the end result. So you can see the terminologies in here, the meanings, right? So the key terms are driver, executor, master, and worker. So you can have many workers, right? And then you can have only one master and one executor per worker or per node, right, in here. And then driver, which contains like the Spark context, right? Which is like the handler where it drives everything. It manages, right, the message or the communications between different nodes. And then so let's, say, we can actually do a quick example using Spark, right? So we want to flip a coin, right? 100 times a fair coin, 100 times using Python's random function, right? What fractions of the time do you get heads? I mean, the expectation is like 50% of the time you get heads if it's, fair coin, but not always because it's a simulation, so it can come out to be like 48 times, right? So let's initialize our Spark, right? So the way that we initialize it is pretty much always the same, right? So you just have to remember it. So you have to import, right, PySpark as PS, and then ps.sql, right? This is one of the components, and .spark session and .builder. So you want to build it, right? And then the master is going to be, we're going to be using local 4, right, as our master, and then the app name, you can actually give a name. I give it Spark lecture in this case, and .get or create. So if exists, this app name exists, then I'll just get it. If not, then I'll create it, right? So this is our, and then you can actually say spark.spark context to get this context. Remember this context that we're just talking about. This is the context that we're trying to create locally, right? This is, remember, this is locally created, and then define, right? So this is the first thing. So now we can actually define and run the Spark job, right? So we want to import random. So random is another library, and I say, okay, I want to do this 100 times. And hence it's really just SC is, remember, it's our Spark context, right? The first thing you always do is parallelize it, right? Because remember, Spark is all about having things working in parallel, right? And then collect the data and then just let them work, right? Assign something to each silo and then let them get the work done and then collect the results, right, from all these silos. So you have to parallelize it always, right? Like sc.parallelize, right? X range n, right? So this is like you're saying from 0 to 100, right? Up to 100, you want to parallelize it, and then .map. This is actually the function where you can actually make all these functions in a sequence, right? So after parallelizing them, you want to say map, right? So, and then lambda, right? This is pretty important too. So lambda, we talk about pandas data frame and then, having lambda, dot apply lambda, right? But this is kind of like the similar thing. So you want to map something to something, right? So this thing is just for every number that you get from this range, right? 0 to 100, right? This thing, you want to map it to random.random. So this will actually map it to a random number, right? And then do dot filter. It's going to be a random, but it's going to be from 0 and 1, right? So you're gonna get like all these like floats, right? Like 0.1, 0.2. So what we're saying is if we get something that's less than 0.5, right? So then we want to filter it, right? So using this again to say, okay, R is this number, and then we want to map it to R is less than 0.5. So this is to say I want to only filter I want to filter out anything that's greater than 0.5, right? So then I want to count it where it's satisfied this condition where it's less than 0.5. That's considered as head, right? So, and then you can say, okay, tails is like n minus heads. So we're counting heads, right? So, and ratio is 1 times heads, right, over n. So doing this will give you the ratio, right? If you don't do it, then it will just give you, you won't be getting any like float as a result. So this is a quick trick you can actually use. So, let's take a look, right? So you can see, okay, yeah, ratio is 0.4. And then we run it again. It's going to be it's the same again. Okay, so we can then do maybe 1,000 times. They say, okay, it's always like 0.4 looks like. So maybe it's not really fair. What if I change this to like is equal to 0.4, I bet it will flip. Not really.